All right, so this is a quick explanation of the Double Algebra Unit 10 Day 6 homework. So just make sure you play it through. If you get stuck on anything and you need an explanation again, you can always pause it, rewind the video, and watch it again. All right, so if I'm looking at number 13, since both of these numbers are inside the radical, I can just go ahead and multiply them right from the get-go. So 10 times 40 gives me the square root of 400. Then I need to reference my list of perfect squares, which I should have made, right? At the top, you should have made your list of perfect squares. And the largest perfect square that goes into 400 is 100. It goes into it 4 times. And the square root of 100 is 10. The square root of 4 is 2. So when we multiply them together, we get 20. Okay, so if you would have done it that way, you still would have gotten the same answer. But don't forget, 400 is actually a perfect square as well. So don't forget to check to see if it's a perfect square before starting, because you could have also gone straight to 20. All right, looking at number 14. 6 and 6 are the two numbers that are in the square root. Because it's multiplication, we actually need to multiply all the parts. So 3, there's not another number outside, so we're just going to bring the 3 down. But 6 times 6 is 36, and that stays in the square root. Now, I also would check and see, is this a perfect square? Because remember, we need to simplify. 36 is a perfect square. The square root of 36 is 6. It comes out of the square root because we took the square root of it. The 3 is still out front. There's multiplication between them, which would give you 18 as your final answer. For number 15, again, there's no numbers outside the radical. They're both inside of the radical, so I would multiply them right from the get-go. 22 times 11 would be 242. Now, 242 is not a perfect square, so I need to simplify by finding the largest perfect square that goes into both of them evenly. In this case, that would be 121, which goes in twice. The square root of 121 is 11, so it comes out of the square root. There is not a perfect square for 2. So we leave it in the radical, and your final answer is 11 square root of 2. Okay, so let's look at 16, 17, and 18. For 16, the first one, there are actually two numbers outside of the radical. So we're going to go ahead and multiply those two together. 2 times 7 is 14. There are also two numbers that are inside the radical. So again, because it's multiplication, we'll multiply those together. 18 times 6 would be 108, so it's the square root of 108. Then we need to find the largest perfect square that goes into 108, since 108 is not a perfect square. And the largest perfect square that goes into it is 36, and it goes into 108 3 times. And don't forget that you need to bring down the 14 out front. Now we take the square root of the perfect square, which is 36, so the square root of 36 is 6, and we bring everything else down. Don't forget that there's multiplication between these, so 14 times 6 is 84. Square root of 3 is your final answer for 16. Number 17, there are only numbers inside the radical, so we can multiply both of those together to get the square root of 147. Since 147 is not a perfect square, I need to break it up into a perfect square and another number. The largest perfect square that goes into 147 evenly is 49, and it goes in there 3 times. The square root of 49 is 7. We cannot take the square root of 3, so we leave it in the square root, and your final answer is 7 square root of 3. Looking at 18. Negative 3 is the only number outside, so we're just going to go ahead and bring that down. But there is a 20 and a 15 inside the radical, so we're going to multiply those two together to get the square root of 300. 300 is not a perfect square, so I'm going to break it up into a perfect square and a number, and in this case that would be 100, and it goes in there 3 times, and we need to bring down our negative 3 out front still. The square root of 100 is 10. Still bring all the other pieces down, and remember there's multiplication between those first two numbers, so your final answer is negative 30 square root of 3. All right, let's go to the back side. 51, we should notice that there's also just two numbers and they're both inside the radical. So if I were you, my first step would be to multiply those two numbers together. So we're going to do 12 times 75, and you end up getting 900 when you put them together. Then I would look and see if 900 is a perfect square. So I would type the square root of 900 in my calculator, and the square root of 900 is 30, so you're done. The next one, they're already both in the same square root, so we need to just go ahead and multiply them. 26 times 2 is 52. Then we need to find the largest perfect square that goes into 52 evenly, which is 4, and it goes into 52 13 times. The square root of 4 is 2. We cannot take the square root of 13, so it stays square root of 13, and your final answer is 2 root 13. All right, number 16 takes this a step further, because this time, when we go ahead to look at number 16, there's actually this minus sign in the parentheses, which reminds me that I need to distribute. So the first thing I'm going to do is I'm going to multiply the square root of 2 times the square root of 8. All right, I'm going to completely ignore this part for now and just worry about this side. Now this is just like what we've been doing on these other problems. So since they're both inside the radical, we can go ahead and say, okay, 2 times 8 is 16. So we have the square root of 16, which is 4. Now that we're done with that piece, we're going to ignore that piece and work on the next one. So the next thing I'm doing is I'm taking square root of 2 and I'm multiplying it by -4. So make sure you realize it's not just a -4, it's actually a -4. So square root of 2 times -4. Well, the 2 is inside the radical, the 4 is outside of the radical. So I don't have 2 both inside or 2 outside of it. So a lot of times what I would do is I would just add a 1 out front to make this easier for myself. So now I know the 1 is outside and the -4 is outside. So 1 times -4 is -4. Since there's no other square root, we would just bring the square root of 2 down. Now remember, now that we've gotten to this point, we have to try and simplify it. 2 is not a perfect square, and there's not a perfect square that goes into it, so that's really the end of simplifying that side. So my final answer is 4, and then minus 4 square root of 2. So then I need to ask myself, are these like terms that I can combine? Well, there's a square root of 2 here, there's no square root here, so there aren't like radicals, so that's actually my final answer. All right, so remember, when you're dealing with distributing, really do one side, then the next side. Make sure when you do the first distributing that you simplify all the way, distribute, simplify all the way, and then look to see if you can combine them. If you can't, you're done. If you can, you need to. All right, so let's look at 17, 18, and 19, which are very similar to that. So again, since there's a plus sign in here, we're going to have to distribute. So we're going to do square root of 3, times square root of 27 as our first step. I'm going to completely ignore this plus 1 for now and just distribute that. So I can multiply both of these because they're both inside the radical, and I would get square root of 81. Well, 81 is a perfect square, so I end up with 9. So now I can ignore that side and work on the next piece, right? So I'm going to do square root of 3 times positive 1, since there's a plus sign there. And again, this is inside the radical, this is outside of the radical. So I'm not going to multiply those two together. Instead, I'm going to put that coefficient of 1 in here so that I know I'm going to do 1 times 1, which is just 1 square root of 3. Then I need to try to simplify this, but there's no perfect square that goes into 3 evenly, so that's as simplified as I go. So I've got the 9, and since this is positive, it would be plus 1 square root of 3. Now remember, on a multiple choice test, that 1 wouldn't be there. It would just be 9 plus the square root of 3. All right, so let's look at 18. Again, there's distributing because there's a minus sign in the parentheses. So my first step is to do 2 square root of 3 times square root of 3. Now, since it's multiplication, we're going to try to multiply everything. Since the 2 is the only thing on the outside, we're just going to bring that 2 down. But these are both inside the radical, so we're going to multiply those two together. 3 times 3 gives me the square root of 9. And again, I keep simplifying this until I'm done. So the square root of 9, we can actually do that since it's a perfect square, and it's 3. We bring down the 2. Since there's no symbol, that means multiplications between them, and 2 times 3 is 6. Then I'm going to have to distribute 2 square root of 3 to -1, right? So we're going to do 2 square root of 3 times -1. In this case, we have two numbers that are outside of the radical, so we're going to multiply the outside numbers together. 2 times -1 is -2. And then that square root of 3 is the only square root that we have, so we're just going to bring that square root of 3 down. Then we need to think, can we take the square root of 3? We can't, since it's not a perfect square, and there's no perfect square that goes into it, so then we can just go ahead and bring this down so that it's 6 minus 2 square root of 3 as our final answer. Okay, last one. So again, there's a plus sign in here, so we're distributing, which means we're doing the square root of 3 times the square root of 15 first. Since they're both inside the radical, that means we can combine them together. 3 times 15 is 45, so then we can take we try to take the square root of 45, and we can't since it's not a perfect square. So we break it up into a perfect square, which would be 9, and that goes in there 5 times. The square root of 9 is 3. We can't take the square root of 5, so we leave it square root of 5. Then we're going to go ahead and distribute to the last piece, which is a positive 2. So I'm doing square root of 3 times positive 2. Now in this case, the 3 is in the radical, the 2 is outside of the radical. I cannot combine them together, so I'd put the 1 in front of here so that then I know I can do 1 times 2, which would give me 2 square root of 3. There's no way to take the square root of 3 or break it up, so since it's positive 2 root 3, I just bring that down. These are not like radicals, so I can't combine them, so that's my final answer. All right, so if there are any of these problems that you're confused on, you can always rewind to that point and watch it again. Also, if the sub or anyone else is able to answer questions, you can always ask them for help. But once you're finished, you need to pass it to the back, make sure your first and last name is on it, and turn it in.